Hi, this is Prem Sir from Team 2.0. We are working on the project to create a robotic arm which is capable of segregating medical waste into color-coded bins using the robot operating system. The main objective of our project is to create a robotic arm to help those who are working in sanitation department. As as in recent days, there are many diseases which are contagious. When humans are involved in this work, those contagious diseases to eradicate those contagious diseases, we can take the help of robotics. A- and the and our project can make the accurate high segregation of medical waste. As humans can make many errors, these robotic arm can come in handy. We are using a lot of hardware for this project. The first one is the Pixhawk version 2.4.8 with buzzer and switch. It acts as microcontroller in our project. And Jetson Nano. It is the CPU of the robotic arm. It stores the data and the algorithms to which the robotic arm has to work on. The base of a project is rover, as the robotic arm uses the rover. It is the base of our project. We are using a 6-dimensional robotic arm in our project. We are using 2x25 saber-tooth motor driver, which is a highly capable motor driver for the Pixel for brushed DC motors. We are using 6 brushed DC motors, each for a wheel in the rover. We are also using GPS module to locate the coordinates of our rover. We are also using a stereo camera and a voice recognition module in our project. The first one here is the saber tooth which we are using, and this is the rover which we have created so far. This is the Jetson Nano, and this is the robotic arm. We are using ROS Melodic on Ubuntu 18.04 and ROS to manipulate and maneuver the rover, which is the base of the robotic arm. We are using Autopilot to load the firmware in Pixhawk. We are also using Mission Planner to plan a mission so that a project can take as much as less errors as possible. We are also using YOLO algorithm, which stands for You Only Look Once. As the name suggests, it has only a single layer to identify the objects. The workflow and functionalities of our project are going to be discussed. In our project, voice commands are given into the robotic arm to make it operate. If the voice command is automated, it directly goes to the waste detection and classification module to identify the waste which is present in the sight of its camera. If the command is manual, it converts this speech to text using specific algorithm and search for the keyword in the speech. If any keyword exists, it extracts and searches it in the waste detection module, which can be created by the Python. And the commands like pickup and drop are used in the instructions. We have 5 phases in our project. In the phase 1, we are setting up the robot base and robotic arm. In phase 2, the ROS is installed and configured for the rover and the robotic arm. In phase 3, we are going to implement voice recognition system, which we have not done so far. In phase 4, we are going to implement waste detection algorithm, and in phase 5, we are going to test it in real-world examples. In conclusion, we can say a project is an efficient and automated solution. It is highly efficient for managing medical waste, and a robotic arm can be deployed in many places like hospitals, clinics, and dumping yards where waste has to be managed effectively. Thank you for listening to my video patiently.